time we'll be looking at different kinds of counting principles, and we'll start from the very basics and then we'll try to give it a little complicated view as well. The first thing that comes to our mind is, okay, before we go to counting principles, let's understand what factorials are. N factorial can be written as n times n minus 1 times n minus 2 till 1. So if I'm saying n factorial, I'm just implying the product of the numbers of n minus 1, n minus 2, n minus 3, n minus 4 till 1. So if you're given a number 4 factorial, then that would just be 4 times 3 times 2 times 1, that is 24. And 7 factorial would be 7 times 6 times 5, 4, 3, 2, 1, right? That's 5040. So that's n factorial. If you're given n factorial upon n minus 2 factorial, you can write it as n times n minus 1. Why? Because n factorial can be written as n times n minus 1 times n minus 2 times n minus 3 till 1. And similarly, n minus 2 factorial can be written as n minus 2 times n minus 3 times n minus 4 till 1. And n minus 2 factorial is already there right here, where I can write n factorial as n times n minus 1 times n minus 2 factorial, right? So that's the same thing. There are two rules that come into the counting principles. The first one is the sum rule and the second one is the product rule. The sum rule states that if sets A and B are disjoint, the size of the union is the sum of their sizes. That's A union B is A plus B. And the product rule is that the size of the Cartesian product of two sets is the product of their sizes. A cross B is A times B. Okay, that's the magnitude. Alright, so where does this fit in to solving problems? Suppose there is an event E1 that can occur in n1 ways, a second event E2 that occurs in n2 ways, and a following E2 a third event that is E3 that can occur in n3 ways, and so on. So there are like n events, right? If the events occur one after the other, then all the events can occur in the order indicated as n1 times, sorry, this is wrong, yeah, so this is for like the first event happened in n1 ways, the second event happened in n2 ways, the third event happened in n3 ways. So how many ways can the n events work? So that will be n1 times n2 times n3 times till n, right? So if I'm saying that I'm given I eat breakfast in three ways. I can have oats, I can have cereals, or I can have pudding in the morning. There are three ways I'll have the breakfast. In the afternoon, I can have pizza, I can have a sandwich, or I can have a pasta dish. So right, three ways I had the breakfast, three ways I could have the pasta, and in the dinner I just want either a rice plate or I want a Subway sandwich, right? A sub. So how many ways can I work through the whole day? Like how can I eat through the whole day? I can eat breakfast in three ways, lunch in three ways, and dinner in two ways, right? So the number of ways I can eat food through the day is 3 times 3 times 2, so that's 18, right? So that is the product rule. So if the event 1 occurs in n1 ways, event 2, that is lunch, occurs in n2 ways, and dinner occurs in n3 ways, how many times do the events occur in the order? That is E1, E2, E3, that is lunch, breakfast, lunch, and dinner. That is n1, that is 3, n2 time is 3 again, and n3 is 2. So that's n1, n2, n3 ways. Okay, so that is the product rule, and the sum rule would have stated that if sets A and B, so the number of ways I could have any one of them. So now I have 3 dishes in the breakfast, 3 dishes from lunch, and 2 dishes from from dinner. And if I had to choose one of them, it would just be 3 plus 3 plus 2. So there are 8 ways I can have a dish. Alright, let's do a question. Suppose a college has 3 different history courses, 4 different literature courses, and 2 different sociology courses. The number of ways a student can choose each one of each kind of courses. So that I can take I can take a history course in 3 ways. So let me just write the values. I can take a literature course in 4 ways. So one course, I have 4 choices to make one choice, and I can take any of the 2 different sociology courses. So The number of ways I can choose one of each kind would be 24. The second question is the number of ways a student can choose just one of the courses. So that's exactly how we solved the breakfast, lunch and dinner question. So it would be 3 plus 4 plus 2. So that's going to be 3 plus 4 plus 2 ways of choosing just one of the courses from the 8 of them, from the 9 of them. So that's 9. A question to solve. This is I think this is a textbook question. There are 4 bus lines between A and B, 3 bus lines between B and C. So 4 between A and B and 3 between B and C. Find the number m of ways that a man can travel by bus from A to C by way of B. So I can take A to B 4 ways, B to C 3 ways, right? So how can I go from A to C going through B? So that's going to be 4 plus 3 or 4 times 3. Think about it. Would I apply the sum rule or the product rule? Given that event 1 was going from A to B and then B to C, right? It's going to be the product rule because there are 4 ways I can go from A to B, that's 4, event 1, and 3 ways from B to C, that is event 2. So it's going to be, for A to C, it will be 4 times 3, that's going to be 12. The second question is round trip from A to C by way of B. So it's going to be A goes to B, goes to C, then C goes to B, goes to A. So that the product rule now, the events are going to be, event 1 is A to B, event 2 is B to C, event 3 is C to B, and event 4 is C to A. Sorry, from B to A, right? So it's going to be 4 times 3 times 3 times 2. Let me just write it down. This is for B. Event 1 would be N1 ways, N2 ways, N3 ways, and N4 ways. We know N1 is equal to 4, that is from A to B. N2 is equal to 3 because of 3 ways between B and C. N3 is going to be 3 again, that's again from C to B. And N4 will be 4. So that's the answer. That's 4 times 3 times 3 times 4. That will be 16 times 9, and that is 144. Alright, round trip from A to C by way of B but without using a bus line more than once. That's the interesting case because here you were able to use it four ways, right? The first time when you went from A to B, then from going to B to C for the first time you still have 3 choices. But when you're coming back from C to B, you can't choose the one that you chose, and you had already chosen one of them, so then you're left with just 2, right? N4 would also decrease because from B to A you'd already have used one of the bus line, so it's going to decrease by 1, so that's going to be 3, right? This is for C. Alright, so that's how you solve this question. Question to solve: how many different license plates are there if a license plate must be a sequence of 3 letters followed by 3 digits? The blanks in black are the letters and the blanks in orange are the digits. Number of ways possible, I can fill the first one is 26, the 26 alphabets in the English alphabet. So 26, I can fill the second blank with 26, the third blank with 26 because 3 letters are followed by 3 digits. But now here it will be 10 because there are 10 digits, 0 to 9. Similarly the case, it's going to be 26 raised to 3 times 10 raised to 3. But what if, given that the letters should be different, so if the letters are different, the first one can be filled 26 ways. Now I've chosen one of them, so I cannot choose it again, so it's going to be 25 now for the second letter, and then now I have 24 choices for the third letter, right? So that's going to be 26 times 25 times 24, but there is no comment on the kind of digits. The digits could be the same as well, so it's going to be 10 times 10 times 10, so it's going to be 26 times 25 times 24 into 10 raised to 3. What if the next condition is given that the letters should be different and the last digit should not be 0? Now here's a good case. It's 26, 25, 24 as the last one, but here we start from the last digit. That's 9. So this cannot be 0, so there are other 9 possibilities from 1 to 9, right? What about this one? So this can take up 10 values, so it's actually 10 times 10 times 9, right? What if you're given that the letters should be different and the digits can be from 5, 4 and 3 and they should be different? So like you cannot reuse the same digit again. So it's going to be 26 times 25 times 24 times 3 times 2 times 1. What if I did not say that the digits should not be the same? So I said the digits should never be the same. Then it is 3 times 2 times 1. But what if I said that they could be the same? So it's going to be 3 times 3 times 3 then. Okay. Alright, next question. How many odd 4-digit numbers are there with no leading zeros and no repeated digits? How many odd 4-digit numbers are there with no leading zeros and no repeated digits? So let's look at the no leading zeros one. So you have 9 right here. Case solved. Now I have 9 times 8 times 7. So no repeated digits, so it's 9, 8, 7. Now I made a mistake here. I did not factor in odd here, right? So for odd numbers, the last digit cannot be 0, 2, 4 or 8. 2, 4, 6, 8. How would I factor that in? Email me your solutions and we can discuss over this. At Vora at UCDS again. .edu. Alright, next question. Find the number n of distinct permutations that can be formed from all the letters of each word, that is, those. THOSE. Number of permutations possible. Permutations is just the number of ways you can place the letters to create new words. So you have 5 letters. Now the first, let's just put blanks for them. The first blank can be filled 5 ways, the second blank 4 ways. If I already used one of the letters earlier, I cannot reuse it again because I'm using the 5 letters that you're given. So it's 5 times 4 times 3 times 2 times 1, because the last blank, you already used 4 of them, you just are left with one of the characters. So there's just one way you can fill the last one. So it's 5 times 4 times 3 times 2 times 1. What if? Okay, another one. Let's try to find the number n of distinct permutations that can be formed from all the letters of each word, JAY, right? You can consider the digits to be, it's actually the letters to be L1, L2 and L3, right? So you can form it as L1, L2, L3, L1, L3, L2, L2, L1, L3, L2, L3, L1, L3, L1, L2, L3, L2, L1, right? 6 ways you can write them, and that's what I've written down them. There's 6 ways to make the, 6 different permutations possible from the letters J, A, Y. What about from A and A? So from A and A, I'll write the same things down as I did for J, A, Y, but here you will see that the ones denoted by X are the same. So L1, L2, L3 and L3, L2, L1 are the same because the two letters, the first and the third letter, are the same, right? So both of them are same, X's are same, Y and Y. So that's L3, L1, L2, L1, L3, L2. Both of them would be the same. So here you see that we have overcounted the arrangements of A here. That is, we counted it to, so there is a multiplied factor of 2 factorial that we need to remove because A repeats itself 2 times, right? So we just say that it's going to be 3 factorial by 2 factorial. The number of letters you're given divided by the number of times each letter would be repeated, right? So if it's A and A, then A is the only one that is being repeated. So it's going to be divided by 2 factorial. What if I said it was A N A N? So then it would have been 4 factorial by 2 factorial by 2 factorial. So let me just write it down here. A N A N would be 4 factorial divided by 2 factorial. So you keep on multiplying the number of times it adds. I'll just make another statement here. If it was A-N-A-N, which is Anana, it would be 5 factorial times 3 factorials times 2 factorials. Okay? Awesome, that's done. Question, if it was anagram, so the same thing again, We know that a repeats itself 3 times, so it's 7 factorial by 3 factorial, that is 840. Next question is, you're given the word j, write it in cyclic form. So like if you're given, like you write it in the form of a cycle, how many permutations are possible? This is called cyclic permutations or circular permutations. Let's start with the word AJY. I wrote it as AJY. Next one is AYJ. Now this would not consider AYJ, so I'll write it down again as AYJ. But when I write it as JAY, I want to write it as JAY again. This already takes care of that, because when I wrote AYJ, it handled JAY. So the circular permutation already handled it. Now I want to write JYA. So then this one already had it in it. So like that was JYA. YAJ would also be handled by this particular circular permutation, that is YAJ, and YJA would also be handled by YJA right here. So as you see, we had 6 linear combinations or 6 linear permutations, and we are just allowed 2 different permutations that handle all the 6 of them. So the problem with circular permutations is, cyclic permutations, is that they're similar to linear permutations except the fact that the start and end are not defined. So we just count each linear permutation would be handled by either of the cyclic permutations, and we overcount them n times. So because AY, when I wrote it as this cyclic permutation AJY, it could have started from 3 points, right? But they all are the same cyclic permutation. So we overcount it every time by n, and so we divide it by n factorial by n, that is n minus 1. So for n elements in a circle, there would be n minus 1 cyclic permutations. N minus 1 factorial cyclic permutation, sorry. Question. If you have 4 shirts, 3 pairs of pants and 5 pairs of socks, how many different outfits could you wear? 4 shirts, 3 pair of pants and 5 pair of socks. You'll be choosing just one of each. So it's going to be 4 times 3 times 5. Right? And suppose 2 of the shirts are striped and one of them, the pair of pants, is polka dotted, and you don't want to wear stripes and polka dots together. How many possible outfits do you have? So here is the funny question. Here is a good question though, not a funny question. You don't want to wear stripes and polka dots together. What do you do? How do you get the answer for this? So you find all the number of ways you can wear both of them. Let me just write it down. So event 1, event 2, and event 3. The first event would be, suppose 2 of the shirts are striped and 1 pair of it. So you don't want to wear stripes and polka dots together. So you wear stripes only. You wear polka dots only. And the third one is none of them. So E1 would be, so 2 of the shirts are striped, right? So you wore a striped shirt, so that's going to be, you have 2 choices to choose the striped shirt from. That's 2 striped shirts that you have, and then you don't want to wear the polka together. So the pant that is polka dotted. So then you have 2 pairs to choose from of pairs. So that's 2, and then the socks, there are 5 ways to choose the sock. Now if you're wearing the polka dotted pant, then the number of ways you can choose the shirt is 2, because you won't be choosing the striped shirt 2 times, and then the pair of polka dots is 1, that is a pant, and then again 5 ways to wear socks. And now none of them would be, you don't choose either of the striped shirts, so you have 2 choices for the shirt, 2 choices for the pants, and 5 choices for the socks, right? So this is how you break down a particular event into sub-events, and you can find the answer to the question. Suppose you have a jar with 15 marbles containing 3 each of 5 different colors. You draw out all 15 marbles one at a time. How many different sequences of colors are possible? So this just means that you have, like, you write it down in 15 letters. It's just going to be 15 times 3 factorial raised to 5, just as we saw for the multiple letters that you wrote in anagram, right? Because the colors would keep on changing, repeating itself. So that's 3 factorial divided each time for the different colors, for the 5 different colors. Okay, services that require a password often impose constraints to prevent the user from choosing a password that is easy to guess. Consider a service that requires an 8-character password using the 26-letter Roman letters, both lowercase and uppercase, and the 10 Arabic numerals. How many possible passwords are there? So you will create 8-character password. So this the value would be there. 36 ways to fill this the first one, 36 to choose the second one, 36 to choose the third one. Right? So when you put it up, it's going to be 36 raised to some value. So just find the number of possible passwords that are there. How many passwords that use no numerals? So just don't put any numerals in there and just find the values, putting the alphabets. Oh, something I missed right here, that you can use both our lowercase and uppercase I choose taken as different alphabets. So it's not going to be 26 plus 10 but something else. So think about what would the something else be. How many such passwords use no numerals? So it's going to be 26 plus 26, that's 52. So for no numerals, it's going to be just putting values in there. No lowercase would imply that only uppercase values and numerals. No uppercase letters would be would only be numerals and lowercase letters. If a computer can guess one password every billion second, how many hours will it take to guess all possible passwords from part A? Just find the number of values possible from part A and divide it by 10 raised to 9. Similarly for the next one, if instead your password can contain only lowercase letters, you want it to be at least as hard to guess as an 8-character password that may contain lowercase, uppercase letters and numbers, how long must your password be? This is an interesting question to look at. Now think about this from the order of function method. How many number of alphabet passwords are possible when you had lowercase letters, uppercase letters and numbers? That's going to be 52 plus 10, that's 62 raised to 8 ways to write it down. So it's going to be 52 raised to 8 is equal to 26 raised to n, because it just contains lowercase letters. What would the value of n be? Let me just write this down for you. I'm going to write it as 26 plus 10 raised to 8 has to be greater than or sorry, yeah, that has to be what would the value of n be? That should be your answer for this question. And I hope you understood what we went through today. We just overlooked at a lot of counting principles. We looked over at a lot of counting principles, and that's the discussion for this week. Please feel free to reach out to me. And there's a question I asked during the discussion, and I would love to hear your answers for that as well. Thank you.